Hello students, welcome to our today's lecture on CE 412 Structural Analysis and Design Sessional 2. In this lecture, we will discuss how to draw influence lines of balanced cantilever bridge girders using SAP 2000 software. In this lecture, we will cover both interior and exterior girders. At first, we need to define our bridge geometry, which you have already defined in your lab report. Here, the letter L stands for the total span and LE is for the anchor span, and we designated the suspended span as LS, and here LC is for the cantilever span length. Here we assumed some relations and also followed some guidelines of SAP2012. After some calculations, we found our total span length of 331 feet, anchor span length of 97.35 feet, and cantilever span of 25.55 feet and suspended span of 85.1 feet. Now we need to model it in SAP 2000 software. Before starting any node any element model, we need to idealize this structure. So we assign the supports as a pin support and in the start and end of our model. And here is our piers. So we assign roller support for our piers, and for articulations where it will release moments, so we assigned our hinge we assigned two internal hinges in these articulation regions. So now let's move on to the SAP 2000 software and prepare our initial model. For that, you need to go to here and start a new model, and we will initialize our model as default units of key feet, and we will use grid only. And for our initial model, we will see how many grid we will require. For example, if we require, this is our first grid, second grid, third grid, 4, 5 and 6. So we will need total of 6 grids in X direction. And for Y direction, we will need only one. And for Z direction, we will need only one grid. So for this demonstration, I will take 2 grids in Z direction and total of 6 grid in X direction. And we will use this as a reference for our drawing. So let's see. In X direction, we will need 6 grids, Y direction 1 grid, and for Z direction, we will use 2 grids. And for grid spacing, we will assign initial spacing and then we will modify it. For example, let's see in X direction, we have the first spacing as 97.535 feet. So let's assign this 97.35 feet. And Y direction, it doesn't matter which will assign, it will not show up in our model. And for Z direction, let's keep it as 12 feet and then go assign OK. So here is our display window. So at first go to the XZ plane, and here is our grid. So now we need to modify these grids. So how we do it? We press mouse right click and go to edit grid data and then modify and or show grid system. And here you will have two ways to define these grids or spacing. I will prefer the spacing option as our model in our model. So let's see. For grid 1, we have spacing 97.35 feet, which is okay. And then we need to specify the spacing of cantilever span, which is 25.55 feet. So let's assign 25.55 feet. And then for the suspended span, we have spacing of 85.18 feet. So let's assign 85.18 feet. And then we have our another cantilever span of 25.55 feet. So let's assign 25.55 feet. And then we have another anchor span of 97.35 feet, which is already present here. So we don't need to modify it. So then press OK and return to the display section. So I don't need this 3D view, so I am closing this window and we have our drawing window here. So before drawing any girder, we need to define its section. So go to the define and section properties section and define frame sections. So here we will press add new property and go to concrete and rectangular concrete section. So for example, let's name it as interior girder. So here it is an important point to note that we are only analyzing in this tutorial, so we will not design from this. So it doesn't matter which depth or width you assign, it will not affect your analysis results. So let's keep it as it is, a 1.5 feet depth and width of 0.83. Let's press OK. So we have our interior girder defined, and then we will draw this girder. So go to here, quick draw frame element cable. So we have straight frame, the section is interior girder as we have already defined. Here moment release is given as continuous, we will modify it if required. So let's draw from left to right. Here we have drawn our full beam and we are done. Now we need to assign the support and restraints as specified in our model. So let's go to our first support and assign here the restraint, assign joint restraints, and here we have pin support, so we will assign pin support here. And in this region we have roller support here, and here we have a roller supports, so assign as roller. Okay, and in the end region we have our pin support, so assign pin supports. Okay, so we have defined our supports, and we are still lacking another thing, which is internal hinges. So internal hinges are actually moment releases in our frame or beams. So we will use moment release in this moment release option of SAP2000 in this task. So let's select any frame. We have used this frame and assign frame release partial fixity. So in this option we will release moment in the end region of this frame. So we release moment 33 in the end region and press apply. So a green donut will appear and you will instantly know that here we have an internal hinge or moment release. Select this and use the moment release in the start of this and also end of this frame. Press apply, and then for this span we will have a moment release in the start region. So in this start we have the moment release or internal hinge assigned. Press OK. So we have defined our model, and now we need to define our unit loads or moving load, as we will need to identify and extract results of our influence lines. So for this, we need to define our moving load, and for defining moving load, we have to go to define option and then moving loads and then path. In this option is the path or lane. We need to define lane before assigning any vehicles or vehicle class loads. So let's go to paths and select add new path define from frames. So we will actually define paths from our frames. So at first, let's see our frame labels. Apply. So here we have our frames 1, 2, 3, 4, 5. These are coming from our sequence of drawing. As we have drawn our frames from left to right, we have our labels defined as 1 from left and 5 in the rightmost portion. So now go to define moving loads and paths and add new path defined from frames. Select for frame 1, we have one path, frame 2, frame 3, frame 4, and frame 4. You can press modify for 4 and 5. Here we have our 5 lanes defined. So path name, we can use path 1 or any name you prefer. So let's keep it as it is and press OK. Press OK. So now let's define our vehicular load, which will be 1 unit load, as we need to find our influence line. So we need to define unit load. So press define vehicles and press add vehicle. Here you have our vehicle name, which is our unit load for influence line drawing, and the unit is keep fit, so keep it as it is and press OK. But here uniform load value, you need to assign a uniform load value, which I will assign 1 and modify 1. So 1 unit load vehicle is defined here. So press OK, press OK. So then you need to define a vehicle class. So let's go here and press vehicle class. And in the updated versions of this software, vehicle classes are automatically defined. So here you can see a vehicle class of unit load is already defined. So we don't need to do anything special here. So press OK. So we have our vehicle class defined. And then we need to define our load patterns. For load patterns, here we have our moving load and the moving load type. Here we don't see anything moving load. So press more and then go here and define it as vehicle life. So vehicle life and self weight multiplier will be 0 and press add. So we don't need our dead load. We don't need to calculate any self weight. So we can assign dead load as 0. It doesn't matter actually, because we will extract results for only moving load. So dead load will not affect our results. But still keep it 0 and we have defined our vehicle live load. So press OK. So now we need to define load case in SAP2000. For this, go to define load cases, and here you have linear multi-step loading case. So go to moving load and modify show load case. Here you have your load pattern defined, but here you have multi-step static. So if we assign this option, we will not be able to see influence lines. So go here and assign is at moving load and unit load scale factor 1. Press OK, add. So you have your selected path definition path 1, and for unit load you have your scale factor 1, and we are pretty much okay. So go to OK, and we have defined our moving load case. So press OK. Now we need to analyze this model. So for analyze, go to analyze and set load cases to run. We don't need our dead load and modal load case to run. We only need our moving load case to run. So select moving load case and we will need to press this run now. But before that, we need to save this model. So press run now and it will come to this window and it will ask you to save this model. So let's give it a name, influence line. So we save this model. It is showing some messages which we don't need to care about. So here we have display and show influence line option. You can see influence lines from here. For reaction, let's see, we need F3. So before extracting our results, we need to know these notations of SAP2000. And for this purpose, let's move on to our slide and see what is relative distance. We need to understand this relative distance concept for extracting our results from this influence line model. So here, for any frame element, you have your two ends. For the start end is designated as ith end and the end is jth end. So from left to right, it is our starting point and j is our ending point. So from here to here, we have 30 feet distance and a point load acting here. So relative distance is actually a fraction of element length. So in this case, our total span length is 100 feet and we have a distance of 30 feet in this point. So our relative distance is 30 divided by 100 equal to 0.3. Here, we need to note a point which is the distance calculation always starts from the drawing sequence. As we have drawn our model from left to right, we need to calculate all the distances from left to the right. So now let's move on to our software. But before that, let's define a section for which we need to extract our shear force and bending moment influence lines. Here we have defined total of 9 sections. So let's go here and let's assume we need our influence line for shear force and bending moment at section A. And this section A is in the middle of our anchor span. So the relative distance will be, here you can see, the relative distance will be from the left. So from left we have 48.675 feet and we will divide it with the total anchor span length, which is the length of anchor span. So for this we have our 48.675 divided by anchor span length equal to 0.5. So we need to find shear force and bending moment influence line at a relative distance of 0.5 in this anchor span. So now let's move on to our software package and let's see our, at first we will extract the results for shear force. So go here, display and show influence lines, and we need to identify our influence line in this anchor span region. So go here and select plot influence line for this element type. So select element type as frame and frame label, as we know this is our first frame. So frame label is 1 and relative distance 0.5 as we have discussed earlier. So we need shear force. So for shear we need to select shear 22. So select shear 22 and press OK. So here we can have our influence line for shear force for this anchored span region. So now here we have another problem, which is how to identify these points here. So for defining these points, we need to extract these results and plot it in Excel. So let's go again to display, show influence lines. Here we have shear 22 and relative distance of 0.5. So go here and press show tables and then copy the entire table data. And before that, yes, go to here and press copy entire table data. And then go to Excel and press and paste all these copied data, and you have our results here for influence lines. So now we need to plot these results. So go to insert charts and select this point, and then we need to select data for our chart. So for select data, press add. Series name will be influence line. So IL for V22 anchor span, relative distance of 0.5. So press X values. So in the influence line, we will have our distance in the X direction and the values of influence line in Y direction. So for X direction, we need to select the distances. So from here to here, we have our total distance, and series Y values will be our influence line values. So here we have our influence line values, and press OK. Press OK. So you have our charts. This is our influence lines. So if you want to show the coordinates, press here and select data labels on. So you can see every point in your influence line in this manner. So this is our influence line for shear force at the half distance of our anchor span. So let's go again and draw influence line for moment in the same section. So go here, cross and select moment 33, press OK. This is our influence line for moment in this section. So if you want to plot again these results, go display, show influence lines, go here moment 33, show tables, copy entire table, and go again in Excel, make another copy of it, and just you need to paste these results and you will have your influence line for moment. Let's change this name, go edit, and series name is influence line for M33. M33. So press OK. So here is our influence line for moment in this same section. So this is how you can draw influence line using SAP2000 software for balanced cantilever bridge. If you want to know the influence line for reaction, press this. Let's assume we need to know the influence line for reaction at this joint 1. So here this is our joint 1, joint 2, joint 3, joint 4, joint 5, and total of joint 6. So let's select this joint and select display, show influence lines. Here joint level 1 is selected already. we need to perform a reaction and reaction F3. So here you may be in a confusion which we will select F1, F2 or F3, and for this I have a chart. For X direction we designate it as 1, for Y direction we designate it as 2, and for Z direction we have a designation of 3. So go here and select F3 as we have our reaction in Z direction. So F3, press OK. So you have our influence line for reaction in joint A. If you want to plot it again, go here, show display influence lines and show tables, copy entire table, go here, copy it, and then just simply paste these results. So we have our influence line for reaction. Let's rename, select data, edit, and here IL for R3 direction, and here relative distance is 0. Okay. Okay. Done. So you can see we have our influence line for reaction, influence line for moment, and we have our influence line for shear.